Zoom out a little bit so you can probably see the whole screen. Oh yeah, there you go. Okay, here we're looking at calcium hydroxide, and cool fact is that it is used to remove sulfur dioxide from exhaust gases emitted by power plants, but it's also used during water treatment to soften the water by removing some of these ions here that cause hard water, if you've ever heard that term. Let's say that we know the mass of calcium hydroxide we're starting with, and we want to find the number of moles of calcium hydroxide. So here we're going from mass to moles, which means that we want to use molar mass as a conversion factor. Okay, again, we're dealing with a compound, CaOH2. So I first need to find the molar mass of the compound. So I've got calcium, I've got oxygen, and I've got hydrogen. Okay, hydrogen has a mass of 1.01 grams per mole. Okay, oxygen has a molar mass of 16 grams per mole. Okay, and if you look on the periodic table, calcium has a molar mass of 40.08 grams per mole. Grams per mole. All right, we've got 1 calcium. Okay, we've got 2 oxygens. We've got 2 hydrogens. So if you add those up, you get 74.10 grams per mole. Again, that's just the molar mass for us to use as a conversion factor. Let me grab another piece of paper real quick so that way I can write the problem now. Alright, so here, since we're going from mass to moles, I can use the molar mass as a conversion factor. So I'm going to start with 325 grams of calcium hydroxide. And I want to get into moles of calcium hydroxide. So I need moles of calcium hydroxide in my numerator and the mass on the bottom. Okay. I know molar mass means that I've got 74.10 grams of calcium hydroxide for every mole. And I'll notice that my grams cancel, and I'm going to be left with moles of calcium hydroxide. Okay, so I'm going to take 325 and divide it by 74.10. So if I've got 325 grams of calcium hydroxide, that means that I've got 4.39 moles of calcium hydroxide.